Hello everyone and welcome to our first lesson for introduction into machine learning. So today we'll be looking at the base concepts of what are the basic definition of machine learning, where can we find most of the applications, and then tomorrow we are going to be looking at the types of machine learning. On Wednesday we are going to look at some base knowledge in statistics, and then we keep going like that. So we're going to look at what is machine learning. Uh, let's think of our phones. When you have your phone, let's say you keep on sending text messages to someone, and then over time, when you start typing something, you see that that text auto picks up. So those are good examples of machine learning because that phone has been able, or the application in that phone has been able to learn the pattern of the kind of text that you are going to that you're using, and then it's predicting and recommending text for you to use. So machine learning is just a branch of artificial intelligence that enable computers to learn from data and then improve their performance over time without you explicitly programming that device or maybe that computer. When we talk about a computer here could be a phone, it could be any electronic device that you're using these days. So here we have an ML. So ML here stands for machine learning. So we have the algorithms plus the data. When we combine the algorithms plus the data, they lead to what we call a model that can improve over what time. So the key features of machine learning that we have to know here is that most machine learning applications are what? They are data driven. Data driven in the sense that they learn the patterns in the data. And then when they learn that patterns, what happens is that they are able to self-improve themselves as as time goes on and as more as they see data related to what the patterns they have learned. And then also when they learn these patterns and then they are capable of making decisions with the new data or any data that they see, it reduces the need for what? Manual rule-based things. Like there is no need for you to know maybe based on mind, or if you are going to look at the house, predicting the house prices of houses, you don't need to go check every time you go look at, oh, when the house changes by a square foot, how can I estimate the price by doing that manually using your calculators? But when you build a model with that data, you can automate that process over time. So how machine learning works. So the first thing we need to know here is that you start with what? The data. Now, before you build any machine learning application, you need to think, what kind of application am I building? What kind of data should I use? When you get the data, you now have to train that model using an algorithm. We are going to see the different kind of algorithms as we move into the different types of machine learning. So also, that model, when it's being trained, it can make decisions or maybe make predictions based on what? Using some new data. So meaning that if you use data to train a model, like in the cases of predicting house prices, any new data that it sees, maybe the size of the square foot, maybe any feature that you're using to predict those house prices, the new data it sees, it will be keep on being accurate in making those decisions. So when we have data, we have the algorithm, then it leads to the model, and then we can go to what? Predictions. These predictions here, we are going to see when we move to the different types of machine learning. So this good flow here is what we call what? Supervised learning as we move on. So let's look at why are we actually looking into machine learning? Why not just use traditional programming? Let's say in the case of the video I posted based on the text mining, also based on the books website that has scraped data from it and was trying to extract different books, their ratings and all those things. Why don't we just use maybe traditional programming to do that? One disadvantage of traditional programming is that every time you need to go and set those rules to perform a particular task. But with machine learning, what it does is that, with data, you plus the output, you can now set those rules, and those rules are what we call what? The modeling aspect. So once you have the data, you have the output, what happens? You can allow that model to learn, or an algorithm to learn that pattern over time, and it will be capable of making decisions for you rather than you coming every time and trying to do what? To set rules to perform a particular task. So good examples of machine learning applications that we will see as we move on. We have what? Email spam filtering, also movie recommendations. For most of us watching movies on Netflix, YouTube, you know, when you watch anything on Netflix, especially when you give it a thumbs up that you like it, they will keep recommending something to you like that because you already get that. It's an algorithm learning your data. It's learning what you like, and then over time, it's capable of recommending what you like to you. Also predicting the house prices. We are going to see this example as we move on. Even voice assistants. Let's say you bought your speaker that is using Alexa. When you say, Alexa, can you do this to me? Because Alexa is capable of recognizing your voice. Every time you say anything to Alexa, Alexa will know that you are the one because Alexa is using your voice to make those decisions. Also in image recognition, let's say to unlock your phone, to unlock maybe your laptop, you use your face. That is an algorithm learning the pattern of how your face, your image looks like. Because any person that is going to bring an image that is not similar to yours, you know, that phone is not going to unlock. So let's look at an example here where we, we are trying to predict the prices of houses. Now we have this, this scatter plot here where we have the x-axis is the size of that house in square foot, and whereas the prices in what? In dollars. Let's say we want a machine learning model that learns the relationship between what? These house prices and what? Based on the size. So we can plot something like this. So the fitted line here is looking at the relationship between what? The size of that house and what? The prices. So this is a good example of what we call the linear equation. Most of us have seen this in high school, which is of the form y equals to mx plus c. As we move on, we are going to see how we can, calculate this gradient. Already we know this in calculating this gradient in high school. We know that it is changing, or maybe junior secondary school is changing y over what change in x. But this gradient that we saw is very applicable in machine learning. That is actually machine learning we were doing, but not knowing. So let's say I already estimated using this graph, I estimated the prices of those houses, to the gradient to be 140, and then I have the y-intercept here as well, 50,000. So this slope here, how do we interpret the slope? So the slope here simply means that for every extra square foot, the price of that house is going to increase by what? 140. Also, with this intercept, the intercept here is just like the starting price when what? The size is 0. Let's say we want to know the price of that house when the size is 0. That price will be what? 50,000 US dollars. Now, when we have an equation like this over time, we can deploy this model and it will be capable of predicting the houses, these house prices for every square foot. Let's say for 1,000 square feet, what will be the house price? We just go into this equation. Wherever we see size, we put 1,000, multiply by 40, we add 50, meaning that the price of that house becomes what? 190,000. So guys, this will be the kind of applications, especially this is a good example of a supervised learning method, which we call regression. We are going to see this as we move on. Thank you so much, guys. That was it for this lesson today. Subscribe more onto my YouTube channel as well as on Facebook to learn most of these tips. Thank you.